The following presentation was recorded at the 2025 Southeast Linuxfest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information on the Southeast Linuxfest, visit www.southeastlinuxfest.org. Come join us next June.
So, 2 disclaimers before I start talking. Number 1, I do work for a company called Flatiron Health. This is something completely unrelated. This is my personal hobby, completely unrelated to Flatiron Health and what it does. Number 2, I will talk a lot about the website called Metaculus. I have no affiliation with Metaculus. They did not pay me any money. I just like what they do, and I like to share that. So here it goes. Here is where we are going. In the end of this, I'm going to show you a bot, my own bot, which is making predictions about real world. It's not a very good bot. It's not a perfect bot. It's not doing absolutely perfectly. I will actually tell you exactly how well it is doing. But before we get to that point, I wanted to go through this steps, which I think are actually necessary to understand before you understand like how you should actually talk about predicting future, accuracy of predicting future, how people are, like whether people are actually good at that, how we can actually talk about it and what helps us talk about it well. Finally, we'll get to the point where AI can do it to a point. Okay, so what is actually predicting future? So here we are talking about event that has not happened in real world, and we're trying to say something about that event. And we'll talk about a lot about what that actually means and how we should formulate that in reality. But it all starts from a person which is not extremely well known. His name is Sir Francis Galton. He is a cousin of Darwin, who's much more well known. What he is well known for is once in 1870, he participated in a county fair. And what was happening at that county fair, there was a competition, and this competition, people, some were experts, some were just passersby, were asked to predict a weight of an ox. There was an actual ox. They could look at it, and just estimate what they believe is the weight. And like they were given little pieces of paper and wrote on it, I believe that the weight is so and so. And in the end, the person who got closest to the weight, as far as I believe, actually got the ox. But the interesting part is that this actually produced unique experiment design, because he actually went to organizers, asked for those tiny pieces of paper, collected them, looked at them, and learned very interesting thing. So in addition to the people who were there and were putting their contributions, there were actual agricultural experts who also provided their opinions. Why are you doing that to me? Okay. And when he took all those pieces of paper and summed them and took the average of all those pieces of paper, he learned that the aggregate estimate, the average of all tiny pieces of paper, was better than any expert. It was really, really close to the actual weight. It was closer when any actual piece of paper there. So the interesting point there is that people as an aggregate, as a group, were much better at predicting than any one person in that group and experts present there. So why is that happening? That is happening because when we are trying to predict something, number one, some of us are experts. We know we kind of can guess closer to the true value. Some of us don't know anything about oxes, I would have guessed very, very far, probably with 50% error. There is probably another person who did not know much about agriculture there who would have guessed with the 50% error to the other side, because errors are distributed randomly. So when they sum them, they cancel each other out, and we're getting very close to the true value. So that's kind of math intuition about why this is happening. Okay, so this is one very interesting example of where we can feel that this kind of works and how that works. So this is the story about Space Shuttle Challenger disaster, which happened on January 28th, 1986 at 11:38 a.m. And time here will be very important, so pay attention to it. So unfortunately, on that day, at that time, Space Shuttle Challenger lifted from its launch pad on Cape Canaveral, and it broke apart 73 seconds into its flight, unfortunately killing 7 crew members aboard. After that, there was a commission which looked into what happened there. It was tasked with investigation. It looked into it for a while, and on June 6th, so look at that, like that's about 6 months, 5 months later, they've submitted the report. The report said the cause of the disaster was failure of O-ring seal. That is something that was rubber, and the reason was the temperature on the field was much colder than it was supposed to be for that ring to work properly. It did not function correctly, and that's what led to disaster. So the commission was able to submit this result about 5 months later. Now look at what happened to stocks of 4 major contractors who participated in the Challenger launch. So there were 4 major companies: Rockwell International, which worked on the main engines and the shuttle; Lockheed, which managed ground support; Martin Marietta, which manufactured the ship's external fuel tank; and Morton Thiokol, which built the solid fuel booster rocket, and which also created the O-ring, which we've learned several months later was the problem. At 11:52 a.m., that is several minutes since the disaster, their stocks started going down. So 20 minutes after the explosion, Rockwell went down 6%, Martin Marietta 3%, Lockheed went 5%, Martin Thiokol, the one with the O-ring, went down to the point that trading was halted because it was overwhelming. Then it returned. By the end of the day, it was 12% down. Everyone else went up to around 3% by the end of the day. So what does that mean? That means that stock market started reacting immediately, 21 minutes in, and this information kind of went there, and by the end of the day, actually by 21 minutes in, it knew the answer. This is this famous paper that I'm quoting from 2003. So why that is a good example and why is that interesting? Essentially, stock market is a way for people to sort of send their votes. Like usually we don't ask people to, like how much the ox weight, but stock market is something where people do have inputs. And this is very close to where people can send their intuition about, oh, I feel that this is more likely than that, and turn it into something substantial, here dollars, that we can track. So this essentially is very close to wisdom crowd. as it was there in one of the previous slides. So what are predictive markets? What is Metaculus that I've already told you about? Metaculus is a website where people are actually asked questions like that about the future, and they asked to provide answers. So this is the place where there is actually a group of people who are voting, and we can see like how collectively what they are believing. This is not the place where people are actually paying money, but if you are participating in a challenge, you're doing well, you are sometimes able to get prizes for predicting well. So that's what's happening. Okay. That was story number 1. Story number 2 comes from a different book. This book is called Superforecasting, and it's by Philip Tedlock. And this person was very interested in experts, for example, experts on TV or in newspapers who provided predictions for the future. Like they would say, I don't know, something like, there is no chance that the iPhone is going to get any significant market share. No chance. That was Stephen Ballmer, who at 2007 was CEO of Microsoft. Okay. So he collected lots and lots of predictions from lots and lots of experts and tried to evaluate like how well they are actually predicting, like he waited when the event happened and tried to measure. He ran into several very interesting problems. Like number one, you can try to look at this particular example and say, like, for example, okay, in 2013, the report is iPhone commands 42% of US smartphone market share. That sounds like a lot. On the other way, that quote, it just says significant. Is 42% significant? We don't know. Maybe it was just meant less than 50%. Then he was correct. So problem number 1, in order to make a good prediction, you need to formulate your question in a way that it would be possible to, when it resolves, to actually decide, like it resolved to yes or no. Number 2, we need to kind of have resolution criteria. Like if it is 50%, we say yes, it resolved to that question being true. If it less something, it resolved to something being not true. There is also another story about how we should actually measure that, but we'll come to that. Okay, so in order to assess accuracy of predictions, we need questions to be good. So we need them to be able to be answered with yes or no or a number. They should have resolution criteria, should be resolvable. Good questions also should have conditions which would tell us like what should be happening in non-trivial cases. And in order to talk about whether people are correct, whether our experts are doing well, we actually need a good metric that would tell us how well they are predicting. Sad story from Philip Tedlock. He learned that 284 experts that he was able to measure, large percent of what he was looking at like was not measurable at all. But for those he would measure, his result was if they were just tossing a coin and say yes or no based on the coin, they would be doing better. So they were not doing well. Okay, so here are some examples of actual questions from Metaculus, and you can see how they follow the criteria that I've just described. So this is a question, will NVIDIA outperform S&P 500 in 2025? And you can see where people are, how that moves through the time. but this is more interesting. What it has is something called resolution criteria. It says this question resolved to yes if so-and-so. It also says the fine print, each stock return will be calculated by taking a just call from Yahoo Finance. So it tells you exactly what we will be measuring, where we will be looking, what we will be calculating, how we will be comparing. So we actually have a way to say yes or no. It has a resolution, has told us how to do this. Okay, this was an example of yes or no question. This is an example of a number question. This one asks, what will be the highest earthquake magnitude recorded during July 2025? Here you can see that we are dealing with a distribution. So people are providing their answer that's participating in the distribution. Again, it tells us what the resolution criteria are. It tells us this question will result with this measurement. The primary source that we'll be looking will be US Geological Survey. Also has fine print. Interesting, actually. Like if there will be, if it will be unclear when the earthquake happened, we will do so and so. So has additional criteria what to do in case something's not clear. So now we can resolve things. Okay. Now we come to a metric, and here is what is interesting here. Like we, of course, can ask our experts to say something like yes or no, but this will actually be kind of bad use of our experts, because our experts are probably more sure in some cases and less sure in other cases. And it would be very helpful if they would express their certainty in a certain way, for example, in a probability. So they would say something like, there is a 70% chance of a rain tomorrow. And sometimes you can think like 70% of chance of rain tomorrow is actually kind of not helpful. What do you do with that? Will it be raining? Do I need an umbrella? But on the other side, this is the expression of uncertainty of the expert in that particular case. And the way we measure whether that uncertainty is expressed well by the expert or the model is the good model should say yes with 70% chance. And if we take all cases where it said the rain will be in 70% of a chance, it should rain in 70% of those cases. That would be perfect, ideal world. So this is a calibration plot where we put predicted probabilities and measured frequency of groups, where we put them, and in the ideal world, they should live all on that line. Okay. I think I'll skip this one. Another interesting thing is what to do when you are asked about a number. Like we talked about the magnitude of an earthquake, and it's kind of hard to tell. I've predicted 6. It is 7. What do I do? Was that a good measurement? So it is very interesting thing what they do on Metaculus with this one. And let me actually show you that one. So here is the question on Metaculus. What will be the highest earthquake magnitude recorded during July 2025? This is a picture I've shown you before. This is the place where if I were to take a prediction, which I would be using, and here you see the controls that I would have. The controls are, I control the distribution. I control the median and 2 quantiles of that distribution. I can make it different distributions like this or like this. It can be very skewed. The point is, in every bar of that distribution, that bar for each number has a probability. So this bar, for example, says this is prediction 7. And for this distribution that you've just created, you've given 10% to 7 and 8% to 6.9, and so on. And this is the way they measure that. So let's go back. So coming back, each probability density functions, there are lots of them. This is the most familiar to most people, the normal one, but there are like plenty of probability distributions. But probability distribution for each its kind of slice will tell you what is the probability of getting there, like getting that in that exact slice. So an example there would be, let's think about bacteria which live between 20 and 30 hours. Probability of one bacterium to live exactly 5 hours will be 0. Like exactly 5 hours is impossible. However, if we ask like, what's about like around 5 hours, for example, what's about between 5 hours and 5.01? Okay, that's a small slice that is quantifiable. Potentially that could be 0.02%. So Metaculus will measure you on your distribution, the actual value that will happen, and what probability did you give to that value in your distribution. And I think that was quite interesting. Okay, so we now have a way to measure yes, no questions, number questions. Okay. Now we'll come back to the book about superforecasters. So remember this guy, Philip Tedlock, who was very unhappy with the experts. So his next task was he actually gathered people, just advertising that we're doing this project, gathered lots of people, asked them to predict real world events, and looked who predicted world events well and like what allowed them to do that. And some people were not very good, but he soon came up with a group of people among those participants who predicted real world events really well. And the next interesting part is that people do have several assumptions, like what would those people be? Some of those assumptions are not true. So number one, they do not have very, very high IQ. That's not true. They are not extremely good at math. That also is not true. And the third one, they are not extremely good at like following news. They are not like sitting there and following news nonstop. That also is not true. So their IQ was somewhere, there were people who had high IQs and were predicting worse. They had tendency to be good with numbers, kind of being able to translate things into numbers. For the third one, the interesting thing is that people who did this best spent on researching a new question, and they got like very odd questions. Like, for example, they could ask you about earthquakes. I don't know if you know about earthquakes. I don't know much about earthquakes. And the task was like, you have to go and research and learn about earthquakes, whatever you can learn. And people who did that best researched between 30 and 90 minutes. So from half an hour, hour and a half. And then they were able to come up with something. On the other hand, I've just told you some things about them. There are some other potentially interesting things. I think the most interesting thing is, that's the quote from the book, foxes beat hedgehogs. And this is from a very old Greek poet who said, the fox knows many things, but hedgehogs knows one big thing. And what is this about? you are not predicting well if something that you're asked about is related to a value that you strongly believe in. It can be something about the world or a moral value, something that you strongly think that is true and will evolve. For a certain reason you believe that, then in that area you are biased. It's sort of obvious. On the other hand, I think it is interesting, and it is also kind of lesson to remember. If someone asks you for a prediction, if it is in the area where you feel dearly, do not make predictions. Ask someone else who's not passionate about it. I think the remaining three are probably more obvious. So people who forecast well do look at points and counterpoints. So if they are asked to decide, they try to come up with arguments for point one, and then turn and try to come up with arguments for point two. And that is the best way to make a good forecast. Number three, they follow the facts. It is possible for them to change their mind if the facts changed. And one of them is actually formulated this like, when I'm thinking about the question, I'm thinking what fact will change my mind. I also thought that it was kind of interesting that for some people, they do not think what fact would change their opinion on something. Final is probably most obvious, but I put it here because it will be important later. So number one, they've evaluated individual people. Number two, they thought, okay, what would happen if we sort of put individual people into teams? And they explored what it will be virtual teams, and people would not know that they're actually on a team, but they will be averaged. Like we'll just say that these people will be red team, we'll take their predictions, we'll average them. Will that behave better? That is true, that behaves better. If you average group of people who are already forecasting well, the average will be doing better. The other thing is if you tell them they are a red team and create them a way to communicate, for example, a forum, there will be a way for them to actually discuss different options and provide different arguments that another person would not see, then they're doing even better. So discussions help. Maybe obvious, but still interesting. Okay, now that we know all that, we can actually go into our bot. Okay, so Metaculus, which I've mentioned several times already, at some point has created competition for bots. That is where they ask, like, okay, now we have this place where we have good questions and we have a way for people to kind of formulate how answers should be. But can people actually make bots which would do this? And this bot, I have created it starting from something that Metaculus suggested, participated in this competition. So I just wanted to show you what it did. It talked to a lot of AI tools, just a summary. So here it no, this is not it. Here it is. Okay. Here is what it told you. It told you you're a professional forecaster interviewing for a job. The interviewer also like knows about forecasting. You need to evaluate past events. You need to think like great forecasters do. So you don't do this on a vibe. You need to kind of evaluate pros and cons. You will be provided something from your research assistant, which will like tell you important things, and then you will provide your forecast. So here is how it goes. Your prompt for assistant will go to AI called Perplexity. If you don't know what Perplexity is, it is an AI which is advertised to stick to the facts. It's like you ask it a question and it actually goes through real research, real facts, and it's supposed to give you true information. So that's what they advertise. You can subscribe to it, you can write a bot which will ask it a question. And here it tells you like, you are an assistant to a super forecaster. Please summarize what will be important for this question. Here is the question. Do not make forecast, just summarize what is important. That's the question. And finally, we are sending, so we are putting what the Perplexity told us into here. We've put the question into here, and then we send this whole prompt to ChatGPT and ask it to make a prediction. Here is how it performed on one question. So the question is, between August 21st and September 11, 2024, this was happening before these dates, will the strongest geomagnetic storm have K index greater than 6, less or equal to 8? So point to note, like this is a good question. It asks us something very specific. It's clear to judge. Okay, community prediction was 52. The true answer, did it actually happen, was no. Okay. Here is what the bot that I've just showed you did. This is the result of the bot on the Metaculus website. So number one, it held 35, so it already was doing better than community, which is surprising because I have no idea what this is about. I don't understand this question at all. So here is the information from Perplexity. It provided some background, told us about geomagnetic storms, current solar activity, provided historical background, also told us something about current forecasts. Interestingly, even though we asked Perplexity to not provide forecasts, it still kind of did a little bit, but it did not confuse GPT. GPT did come up with an analysis. It was like saying, okay, I understand the question. Here's what I'm being asked. Here are the current trends. What should I do? These are my arguments. Yeah, the ask for the model did not work out here, but it did come up with final probability. It did submit it. So, does do something, does something useful, definitely does better than I was able in the time it was able to do that. How good is that? So in that competition, there were 55 bots. This was bot number 44. So not perfect. Do AI bots do better in general? This was bot which came first. And now you know what this chart is. This is actually its calibration plot. Calibration plot means that gray lines are there the perfect place is. Like this is 70%. When the model said 70%, in 70% time it was correct. Yellow points are where the bot was. And it was like kind of summing every time it said 60% into this diamond. You can see that it's not doing that bad. It's actually pretty impressive. The next question, of course, is like, is this the end of humanity? Like, are bots doing better than humans? And of course, Metaculus has already thought about that. What they did, they compared their bot competition to their humans, because they also have humans answering exactly the same questions. So far, we can brief out. So far, in general, human forecasters were better than all of the bots. They've also tried kind of similar technique to what Philip Tetlock was doing. They created a team of bots and a team of humans, kind of taking the best bots and the best humans. And the team of best humans still overdid the team of best bots. So far, humans are doing better. Final thing before the summary. So in that bot that I've showed you, what could have happened better? It was not a best bot, I've told you already. So number one, it only went for one source of information, perplexity. Better bots, the ones which perform better, went to several sources, kind of went to different places which provided better picture overall. Another thing, remember that human people performed better than they were in discussion. So those people created several forecasters, like several AIs. They were asked to behave slightly differently. They had a sort of slightly different intentions and personalities. They asked them to do predictions. And then there was one person who said, who looked at all those, say, 4 different predictions. Say, this person with this kind of background predicted this. This person with this kind of background predicted this. What is now the final forecast from that? And that also helped. So, final summary from here. I hope I have shown you that forecasting real events is possible. It can be done by a group of people or AI. Group of people still do better. We do need way to ask questions very precisely and to formulate what would be the good answers and to find a good metric, because in order to evaluate whether we are doing well, we need all that. As humans, or probably AIs as well, it is important not to follow agenda. If you follow a particular agenda, you're bad at forecasting. And finally, exploring pros and cons and looking at different ways helps. That's it. There's a question over there.
So do you think the humans did better than the bots because we inherently have a much larger data model to work with inside our heads?
That I think at this point still have better access to data because the bots did not have a way to do research actually at that point. At least the bots that I've seen so far. So in case you can imagine that human person comes to something and can ask several additional questions and do research on them, to sort of come back and incorporate that. Bots were not doing that at this point.
And the group of humans against the AI, were there any experts there, or was it just the general like super forecaster?
This was people who performed best on this group of questions, as well as bots who performed best at this group of questions, essentially. Kind of similar. That's it. And thank you.